everybody, where we are continuing our graphing discussion. If we remember our graphing steps, just open the YouTube chat just in case someone has a question. I can see it. Perfect, thank you. Graphing steps, it's always good to remember them. You should by now. We have our warm-up step where we may find a y-intercept, see if what kind of function I'm working with, what do I expect, if you expect anything. Just getting into the right mindset. Then we had our asymptotic behavior. Ooh, that's an ugly H. Where we analyze the function and we see what's the long-term behavior, are there any asymptotes, so on. We might not know the behavior close to the asymptotes perfectly, but when we get to increasing, decreasing behavior, that asymptotic behavior is sort of completely figured out, and you can pick the arrows according to where it's increasing and decreasing. So I don't worry about fully answering the asymptotic behavior of the graph close to the asymptotes. I just want to know if there are asymptotes. What's the long-term behavior, and so on. So for step 3, we analyze the derivative, see where's the function going up, where's the function going down, critical points, and so on. Then we looked at concavity, analyzing the second derivative. How is the graph bending? Where is it bending up? Where is it bending down? And so on. Now, if you have all this information, or if you're given this information, either way, there is a fifth step where I want to put all of it together and graph the function. And that's something that's easily overlooked and not given enough attention to in books. Can I put everything together and see what the graph looks like? Can I put all the pieces of the puzzle together? That's not that easy. So I want to devote some time to just that step, because there is a midterm question exactly like this. But it's also very important to be able to put the pieces together. So we're, eraser mode, problem, same problem set. I'll just move on to number 4. Why not? So now I see I have a y-intercept there. So that's kind of nice. F of 0 is 1. So I just number it so I have sections and groups of information. It helps me. That was the whole point of the steps. Y-intercept, f of 0 is 1, so I'll keep that in mind for later. Asymptotic behavior. Now they give me, I'll drag this back and forth when I can. They give me some other information. F of 1 is 2. I'll use that later. I have to use it if it's there, but I don't care too much right now. F of 4 is undefined. Now, admittedly, it should be stated a little bit more clearly, but that is going to be a vertical asymptote. I will try in the test to be a little bit more clear. For our types of functions, when it's undefined, the function, that is a vertical asymptote. Unless there's a whole log function section where the graph doesn't even exist. It still has a vertical asymptote at that end, at 0. Okay, so don't read too much into this. The information is a little vague. I'll try and update that to say vertical asymptote at 4. Then we have our limits. Far to the right is a 0. Far to the left, I am just copying it down because I don't like to write on the PDF. It never looks as good. So this then tells me I have a horizontal asymptote y equal to 0 on the right only. So, I mean, there's a fair bit of information here. So let's get a graph going. so I don't forget anything. Far to the left, I'm going down. Far to the right, x-axis, which is where the line y equals 0 sits. Don't know how I'm approaching that yet. Vertical asymptote over here. I'm going to put it fairly close because I suspect last time, remember, we had some problems running out of space on the top right. So I want to give myself some space on either side of the vertical asymptote. And that's going to sit at 4. Again, I have no idea how it approaches that vertical asymptote. And I'm also not expecting myself to know. Because I know step 3 will tell me that right away. I have a y-intercept. Now, I might move this later on. Maybe I have to fit a lot of stuff in between 1 and 0. So I want more space maybe. Right now, I'm just going to put it there temporarily so I don't forget that I am given a y-intercept. I'm also given a number for the y value. Whoops. When x is 1, it's a 2. Okay. Well, maybe I'll shift that a little bit later if I need more space, but I have that point that I have to go through. Okay, let's see. That is everything I can do. So pay attention. Maybe I misread something. Maybe by accident. Maybe on purpose. Definitely check up on me. So we have two y values. Asymptote vertical, asymptote horizontal, long-term behavior on the left. That's everything about the function. Now I'm moving on to the table. Results. I don't see the detail of the table. So let's do that somewhere. There's some space, sure. And it says to split up the table at 1 and 4. Okay. Derivative. I have the sign as plus, minus, plus. It then says at 1 it is 0, at 4 it is undefined, which makes total sense because I have a vertical asymptote at 4. So that would be a problem. There can't be a slope if there is no graph. Okay. So I have an upslope, horizontal tangent, downslope, 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 bad times, upslope. Bad times for a different reason this time, right? Where is it? This looked very similar, yet I had a vertical tangent line because the function was defined. This derivative is undefined, but because there's no graph, there's a vertical asymptote. Different reasons. So I have to put information together to see why things are the way they are. Try and get clues from other places as well. So I have a critical point here, and it's a little turning point. I'll put that in to remind myself. Then I am, let me think carefully here, and please check up on me. I'm increasing up to x equal, no, see, I already made a mistake and no one says anything. I, of course, did that on purpose. I would never make a mistake. No one said a thing. X is equal to 1. That's where the critical point is. That is this guy. That is where the little crest is happening. Not exactly like that. I'm just reminding myself. See, no one said anything. You have to check up on me. Then at 4, there's clearly a problem. But it's not a critical point or anything. Okay, so I'm going up from left to right towards this turning point. Of course, going through the y-intercept, turning up at x equal to 1, then coming down. So obviously this bottom arrow is how I approach the asymptote from the left, not the top. Then, after the asymptote, at x equal to 4, I'm going up somehow. Well, it has to be like this, right? Not linear, I know. It's just a reminder. So it can't be this top arrow. It can't be this top arrow for the horizontal asymptote either, because then I would have to turn around and come back down, and that would be a decreasing section, which doesn't exist. Okay, so we'll make it nice and curvy after we've verified the concavity. So I just want to have lines to remind myself the basic trend, exactly how it bends. I do suspect it's bending down always, but we have to confirm it. So then we go to step 4, where we see, I'm reading this off, something's happening at 4. Well, obviously there's an asymptote. Something will always be happening there. And it is, as I suspect, negative. So I'm bending down, bending down. What is happening at that? Well, it's going to be undefined because of the asymptote. So pretty basic concavity, always bending down. That's easy to remember. And that also fits with what I suspect. So let us do this in sections. I perhaps am not going to go as wide because it doesn't matter, right? I'm going to turn, I'm going to hit my y-intercept, and I'm going to go down. It's going to eventually get wide by just going further down, but that's as far as my graph shows it. Then I'm going to go from the turning point, bending down towards the asymptote. I don't necessarily have symmetry here. I just bend to whatever is comfortable. There we go. Then it's just going to be a very simple, straightforward, sort of rational function looking portion on the, whoa, come on, not that bendy, on the right here. Simple enough. And there we go. Oh, everything came together very nicely. So sometimes it sort of looks familiar. This could come from, oh, I don't know if this, yeah, this could come from a rational function. Doesn't have anything too fancy, but I don't know where it comes from. And it also doesn't matter. There we go. Easy enough with some practice. I zoom out a touch. Oops, that's too much. Too much zooming. No, stop. At least you can see the whole question. Question in the chat. Are there questions where you're asked to show the function given information like this? No, I'm not going to bother with that. I never like those questions. Because honestly, my experience with functions, I don't feel at this stage is really enough to guess what the function looks like. I just happen to see basic things like this that often happens in a rational function. But then there's also other stuff. And the rational function will have to be much, much messier. And I don't know what that looks like. I haven't drawn enough complicated rational functions to have the experience to know. And there's too much variety. So we're not going to go that way. Given some information, what's the function? No, I have no idea what the function is. I also don't really care. That doesn't seem like a worthwhile question. Ever, really. No. It seems too much variety in functions that could give you graphs. And I don't know how fast this guy's bending, right? I don't know if I have symmetry. If I have symmetry and this was sort of a parabola shape, then yeah, I'm thinking more rational function. But if it was lopsided and unbalanced, well, whew, that's a different game. And there's so much variety, I really can't say. Yeah. It feels like a waste of time to guess. It's a stab in the dark. I have no idea. Too complicated. Too complicated. Well, I think we can fit in one more. Why not? I hope that the next one is different looking, but I really don't know. Let's have a look at it. That's a lot of Y values. Ooh. Yeah, okay, let's do this one. I have different horizontal asymptotes. That could be fun. Let's go with that. Let's do that. I see some silly questions in YouTube. Of course, I'm not going to respond to that. I'm staying on topic. So we are looking at a problem. It's in our problem set 9.4 and it's number 5. Okay, so we have a y-intercept at 1 again. Y-intercept. Limiting me. I have a lot of points actually. Look at all these points. That's going to be annoying to graph perhaps. But we'll try and get through all those points. We have to just remember that there are points I need to hit. So I just need to keep it in mind. I'm not going to copy them all right now. Then we have some limits. We didn't have any undefined function spots, so no vertical asymptotes. Like last time, we have a limit of 2 on the far right, limit of -1 on the left. So that means I have 2 horizontal asymptotes. I have, whoops, y equals 2 on the right. The line y equals -1, which is on the left. All right, that's interesting. So at this stage, yeah, maybe I can get a graph going here. We have enough interesting things to put on the graph. I want to give myself enough space. What was the top one? 2. I'm going to have to put that in the middle. I don't know if there's much happening above it. Doesn't seem to be, but I don't know for sure. So I know that's on the right. I don't know how I'm coming towards it. The graph can cross it and then come down to it. But the increasing decreasing behavior is going to tell me that, so I'm not too worried about it. Let's put the other one over here, -1, and that is on the left. Perhaps it stays in this band. Perhaps it goes above and below it. I don't know. I know some people think that you can't ever cross horizontal asymptotes. I don't know where they get that. Whoever told you that is not the best instructor. Vertical asymptotes, of course, because then I would have a function. It's undefined there. But horizontal asymptotes, oh yeah, no, you can go up and down. It's just eventually, long term, all the ups and downs are sorted, then it's going towards that y value. I do see something in YouTube. We're not talking about basic function concepts now. We're graphing this guy. You'd have to come to an open Q&A session for general questions. All right. We have something, and we have a y-intercept, right? Y-intercept. So what was this guy? 2. So the y-intercept sits here at 1. Okay, so I'm going to have to go through that. And at this stage, perhaps it's a good idea to put these points in. I'm going to need them. I'm going to need to not forget them. So let's do that. So it says at -1, let's put -1 over here. My y value is 0. Oh, it's an x-intercept. At 1, my y value is 0. Okay. At 2, My y value is 0.5. That's very wobbly, but okay. So I have these points I need to hit. Hopefully I have enough space. I might not, but then I'll just zoom in. I have that luxury at least. So we'll just remember we have to hit these points. How? I don't know. We'll see. I'm actually going to get rid of this dotted line. It's way too wobbly. Okay, let's see what step 3 tells me. And maybe it will give me shine some light on what's happening here. So I have, get rid of that, give me some space. I have an x-axis, a number line, x-axis, that is split up at 0 and 1. And it gives me the derivative and the signs of the derivative. I'm reading it off the question, of course, plus, minus, plus. But do check that I'm actually reading it correctly, since there may have been situations where I go too fast and not read what is right in front of me. So 0 and 1, plus, minus, plus. Okay. Then the derivative function values at 1 is a 0. At 0 is undefined. Whew, that's going to be fun. Okay, I have no idea what this graph looks like. I'm exploring it with you, making it much more fun. Undefined, that's what it says there. Let's hope there's no typo. Upslope, bad times, downslope. Downslope, horizontal tangent, upslope. Okay. Now, remember the function is defined everywhere. And if I then have a derivative that's undefined, that's going to have to be, for us, a vertical tangent line. Can that even happen? At 0, which is at this y-intercept, there's a vertical tangent line. Let's just make a thick line like that. Actually, no, I can do a bit more, because I know it's going up into that point. So I'm going to go up, and I'll fix exactly the curvature later. And then I'm going to go down. Okay, well, that does fit with the fact that I have points around it lower. So that's okay. So I'm going increasing all the way through this x-intercept to x equal to 0. So I'm going to go up like this, which means this bottom arrow is not happening, because then I would be decreasing, and that's not the case. Okay, so that's okay. Everything fits so far. 0 to 1, I'm decreasing. To where? Oh, I have this point here, and this is a turning point. So I'm going to go down there. We'll fix and let them meet up nicely later. And then I'm going to go increasing through that point they gave me to the horizontal asymptote, never turning again, which means that top guy is not what's happening. So when we draw this, we'll zoom in a little bit. But I have a lot of detail here in a very small space, but that's okay. So everyone's still hanging in there. Everything's making sense. Everything's fitting together so far. Fingers crossed for the concavity. This one seems a little bit, I don't know if it's more complicated. It's always a little bit tricky when they give me so many points that I have to get through, and I don't have the flexibility to just move them to a nice, comfortable place. That's always going to be a little bit annoying. Sometimes they're there, sometimes they're not. It depends. So, step 4. Second derivative information. They tell me the x values are split at 0 and 2. I get the second derivative. sign is plus, plus, minus. Second derivative is undefined at 0. It does kind of make sense because the first derivative is undefined there. I mean, it's not a guarantee, but it's going to have to be some very, very strange. No, it has to be. Usually, not always. They didn't even tell me what's happening here at 2. That's nice. They didn't even say anything. Oh. They could have at least have given me a 0 or something. Maybe it's just nothing. They didn't tell me anything. So I'll assume as little as possible. That's okay. I don't necessarily need to know what happens there. I'm bending up, bending up, bending down. It's going to have to be a 0 then. It has to be one of them because that's where these points come from. Remember, they come from the check. Second derivative equals 0 when second derivative is undefined when. Only those x values that come from these are featuring in my table ever. So it's going to have to be a 0 then. I hope. Let's see. So I'm bending up, bending up, bending down. I have an inflection point at 2. Bending up, bending up, bending down. Inflection point at 2. Okay, so that works. I'm bending up. It's very slow, but I am bending up very slowly. Then I'm bending up again through this turning point to the inflection point. Okay, I can see the cup there. And then it turns to bending down, which it has to. It has to bend down to that asymptote. If it's coming at it from the bottom, it has to. So let's go right to left this time for a reason that I'll show soon, because on the left there's something I want to illustrate. It's actually, let's do the middle. I don't want to make this. Let's say I do it like this. But then when I come at the inflection point from the left, I maybe come at it at a weird angle. I want it to be smooth, right? I don't want it to be sort of pointy here. But I think we're okay. Let's go from this turning point into that inflection point, nice and smooth. That was pretty good, if I have to say so myself, because no one else is saying it. I have to. You have to give yourself compliments. Why not? Now, this one's a weird angle for my hand. I have to come at it nice and sharp. Sharper than that. It's vertical, remember, and then bend away, yet still meet it horizontally here. That's not bad. Good job, me. Now here is where I want to illustrate something. This can, with the spacing that we've given ourselves, this can be an opportunity to make a mistake. I know what I have to do, but it's so easy to forget. And I've seen people do this. I'm mentioning it now so you don't do this. Here's what people do. They know, okay, I have to come at this. I'm just going to move my 0.5. It's in the way here. Get rid of that. I have to be sharp here. Okay, I'm bending away from it. I'm bending up. I'm good. Towards my x-axis. Okay. Now remember, this is just a point. It's not a turning point or anything. I have to just go through this. So they go, and maybe they're a little low, right? Okay, let's correct that. I don't want to be too horizontal, but they come at it very flat. And now they think, well, I need to get over here. So now they put a little bend in it and then try and come down here and trying to get low to this line. And see how many turns, technically bending up, bending down I see there. There's a little bend up. Technically there's a bend down. And that's not in my tables. I can't just bend it so I get to where I want to go. It doesn't work like that. And I see people get very wobbly just trying to get through a point to where they want to go. And I have to subtract marks for that because that is not right. That's not supported by the information. There's some changes in concavity happening here, and that's not in our table. It has to be all bending up. And it's really because they came to this point too low. Now, it's because this point is so wide. It's really tricky. To help yourself, honestly, just move that point. I have no problem letting this scale be totally weird. Focus on the shape of the graph. I'm never going to fault you for the shape of the graph. Actually, what I like to do sometimes is I don't even mark that point. Oops, get rid of it. I don't even mark it if I had the luxury to do that. I am focusing on my shape, nice and sharp, bending down to the asymptote. See, nice bend. Then, oh, you know what? That happens to be where -1 sits. Oh, but the spacing isn't the same. I don't care. It's some weird scale. We don't need to know. The shape is way more important because if you have wobbles in your line, that's changes in concavity, and that's not right. I don't care if you adjust the scale to move these points. You're indicating the point. It's -1. It sits right there. Some weird scale is happening here on the x-axis. I don't care. I am interested in illustrating the features of the graph. I'm not a computer program that can make the curvature and the lines perfect to scale. That's sometimes really hard. Focus on the shape. Get nice bends where you need to, angles where you need the angles, and let the points, they're still relative to each other, correct. The scale and the spacing does not have to be perfect. I want to avoid bends and wobbles and things that are not supported by the information. That is the most important thing. And if I, by some random accident, you feel I'm too harsh with your graph, when I've said this now, you said the shape is the most important thing. I put the points in the relative correct position. Did you still subtracted something? Please come back. Check. Mistakes can happen in the grade. Check that I've marked everything, and if you're not sure, ask me. It's all good. Focus on the shape and the bending and the angles of your graph. Which is why I like the questions where the specific points are not given. If I didn't tell you that there's an x-intercept at -1, you wouldn't care. You would just bend it nicely and let it cross where it crosses. Sometimes it's better to not know where the y values exactly sit, so I can focus on the shape more. All right. So we've covered a good number of examples. To get the hang of this, there are, of course, more problems. Check them out. See if you need practice and what they could look like. But we're not going to stray from this for the midterm. It's going to look like this. The information will be presented in a very similar way. So you know that you're practicing those problem book questions. Every question is helping you for the midterm. Now let me just bring up the schedule here real quick. I tried to open it. Let's see here. Does that not work? There we go. That's April. That's not what I want. In March. Yes. March 10th. That's today, right? So we did our graphing. All the steps are now covered. Tomorrow, we will move on to the next chapter, even though there is more graphing videos you can watch. I wanted to put it on, I wanted to attach it to a weekend. So I've made videos where I go from start to finish for every type of graph, every one of the 5, from start to finish. I'll put that in our playlist. I made it a yellow block because you decide. Do you want to watch it all? Do you want to watch just a specific type, just a specific step? You decide how you want to use it. I apologize in that I was experimenting with the cat. He can get a little annoying, his voice, but it's there for you to use as you want. Maybe you like the cat, mix it up. I'll put those in the playlist. Use it as you want, just more practice. Okay. And we will tomorrow move on with chapter 10, which rolls over into next week. So even though we are essentially done with our graphing topic, there is some more that I give you time on Friday. Watch it if you want to do what you want to do. So technically, that's what is happening on Friday because it's a lot. You might need the weekend, so I wanted to put it there. So please take a look. The schedule has been updating a couple of times. I don't announce it every single time. Always have a look at the schedule as you start your week to see what's coming up. Are there any questions or comments at this stage? All right. Then off topic. Okay. For the oral tests, can you just remind us how they work? Oral test, all basic concept questions, no calculator needed, no book needed, no calculation, no writing down, nothing. Just concept question. What is a derivative? Right? You know it or you don't know it. So during any of the red Q&A blocks, first come first serve, you tell me, look, I want to do my oral test. Can we do it now? Then we do a private call because I need to see your face so that I can make sure you don't look in your book or cheat. I ask you 7 to 10 random concept questions, and that will be that. Uh, it'll take less than 10 minutes. The couple that I've done, I think it takes less than 5 minutes. And that's it. Yeah, simple as that. I just ask a few questions, you answer them. Nothing complicated where you need to write anything down or calculate anything. You can all do it in your head. And I will cover material that is from the beginning to maybe a couple of videos. So let's suppose you do it Sunday morning, right? I will ask you everything up to graphing, but I won't ask you about chapter 10. It's too recent, right? So I'll stagger it a little bit. And if you do it, for example, let's suppose you do it April 11th. In that Q&A session, you tell me, I want to do my oral test. We do it. I can ask you everything up to chapter 13, or topic 13 rather, in my numbering. So the longer you wait, the more topics you have to cover. It's up to you when you want to do it. All right. Definitely ask. Yeah, it's all good. You decide when you want to do it. If you miss it, Sunday the 18th is your last chance. If you come to me after that saying, oh, can I do my oral test? No, it's over. You've had so many red blocks. Look at all these scattered throughout. There's always a time. Sometimes in the class, we have a red block. On the 17th, that's a red block. You could do it then. All right. Think about it. See if you have any other questions. Otherwise, we will continue with the next topic tomorrow. Thank you.